Hey there, you crazy Calc kids. I want to do a few problems for you from your packet. These were requested by some students, so you should thank them later. Let's look at number 5. We're going to dive right into this. Number 5. Looking for your limit as x approaches 2. Okay. When you plug in 2, you get 0 over 0, which you don't know what that is. Nerfing means nerfing. So we have to see if we can factor this somehow or manipulate it. Well, I know x squared minus 4 factors into x minus 2 times x plus 2. That's a good old thing we should have learned a long time ago. Now, if you look at this, there has to be something it factors into. If you don't know it off the top of your head, that's fine. Divide that top part by x minus 2 or x plus 2 using good old synthetic division and see if they work out. But I know from my tricky days back in good old Algebra 2, that does factor into x minus 2 times x squared plus 2x plus 4. Alright? It's an old trick. Alright. So now our x minus 2's cancel, and now we plug in that 2. So we do 2 squared plus 2 times 2 plus 4 all over 2 plus 2. So when I do this, you get 2 squared is 4 plus 4 is 12 over 4, which is 3. That's how we get D. Alright, so that's 5. Next one, number 18. Alright, this is one, I'm going to infinity. Whenever you're going to infinity and you have a fraction, that's when you're going to use that rational number rule, that fraction rule. If the powers, if your power on the top is smaller than your power on the bottom, that's going to go to 0 because the top's not going to grow as fast as bottom. If the power on the top's bigger, it goes to infinity. And then if they're equal, you use your leading coefficients. Okay, so this one I'm going to FOIL out. So you get 2x squared plus 1. And the bottom FOILs into 4, or not FOILs, that's the extra rule, 4 minus x squared. So they're both x squared, so I take my leading coefficients, and I get 2 over negative 1, or negative 2. (28) and 29, both of these are looking at the same function. You're looking at your step function. That's what the greatest integer function is. Oh no, Moby. It's back. That's the round down function. Alright? So you have a closed dot, open. It looks something like this, right? 1, 2, 3, 1, 2. Okay? Negative 1, negative 2, negative 3. Open, over, closed. Open, over, closed. Open, over, closed. Again, it's the round down function. You got to know the step function. Sometimes it's written like this. It's the greatest integer. So for like x equals 1/2, what's 1/2 round down to? 1/2 rounds down to 0. You can tell if you go over to 1/2, well, it's 0. Now, what's the limit as you approach negative 2? Alright, so when you go negative 2, discontinuity. Well, when you approach negative 2, from the right side, it's negative 2. But from the left side, it's negative 3. Negative 3 does not equal negative 2. Your right-hand limit does not equal your left-hand limit. Therefore, the limit does not exist. Quoted by Regina George. Not Regina George. Oh no. You guys can limb-base me tomorrow about it. One more. This one's a tricky wicker biscuit. It says, what's the limit of this beast as you approach 0? Okay. This was probably the hardest one I thought in the packet. So let's think about it this way. as x approaches 0 from the right, from the positive side. 10 to the 1 over x. Well, 1 over x is going to get really, what? As you go closer and closer to 0, it's going to get really big because you're dividing by like 1 over 0.000100. So that's going to go to infinity. If that goes to infinity, then your y goes to 0 because the bottom's getting really big. 1 over anything really big is 0. Now, as my x approaches 0 from the negative side, 1 over x is going to go to negative infinity because it's going to get really big on the negative side. So 10 to the 1 over x is going to go to 0 because you're ending up with 10 to a negative power, so you get 1 over infinity, 1 over 10 to the 1 over x, right? So that's 0. Now if that goes to 0, then y goes to 1/2. So your right hand limit does not equal your left hand limit. Because of that, it does not exist. Okay, I hope this video is helpful. Enjoy the rest of your day.